Hello, my name is Joe Carlson. I'm a developer advocate at CloudQuery, and I am joined today by Herman. He's the director of engineering at CloudQuery, and today we're going to be talking about managing data pipelines. I don't know about you, but data pipelines always start simple, and then they get crazy for a lot of different reasons. So we're going to be talking about some of the reasons, like the history of data pipelines, why data pipelines get crazy, and then how to prevent it today. Hopefully. And we'll see what happens. Who knows? Anyways, Herman, thanks for joining me.
Thank you. Hi, Joe.
I'm doing great. I'm doing great. Also, by the way, I'm just starting my day. Herman is just ending his day. The beauty of time zones.
Yeah, no, it's going to be good. I'm looking forward to this discussion. Let's jump in.
You better. All right, let's just jump in. So first of all, for people who don't know what data pipelines are, could you briefly just give an overview describing what they...
Yeah, sure. So data pipelines, I have this mental picture, like mental model. I think we can probably put a picture up on the screen now.
We'll pop it up.
Magic of editing.
Mm-hmm.
But in my mind, I always think like data coming in on the one side, on the left-hand side, usually in my picture. And then it goes through various stages all the way through to some end destination. And traditionally, that end destination was a data warehouse. Nowadays, it could be all sorts of different places, but you probably have a data warehouse in there somewhere at the end, and then maybe other destinations as well. Maybe that data gets fed back into the beginning of the loop for AI purposes or whatever the case may be. So data pipelines come in various shapes and forms nowadays, and they can get pretty complicated, but the basic components usually are like you have sources that feed some data in, you have destinations that the data is going to, and in between you have transformations that can change the data in some way, and you have some systems for checking that the data quality is okay along the way, hopefully, maybe visualizing some of the outputs. And that's kind of the main idea of data pipelines. But,
yeah, it makes sense. I know. I envision the same thing too, left to right. And sometimes it loops around. Maybe it does something. Sometimes it's being like transformed. Maybe there's multiple data sources kind of coming in and creating a data flow. But at the end of the day, all we're doing is basically taking data, transforming a little bit, and maybe loading into another data source.
Yeah. It sounds easy.
The other thing too,
put it that way, yeah, it's so easy, right?
And exactly, anyone can do it.
Yeah.
But I think you brought up an interesting point too, that this big data or like large data movement is still relatively new, and a lot of companies still have these old legacy systems. So like data pipelines don't look the same for everybody. It's very different for, they're loading from different sources. It needs to go different places. The data is performing different kind of functions like analytical, whatever. So it can look really, really different. So I want to talk a little bit about ETL. So I understand like CloudQuery is a data movement platform. We do a lot of extracting, a little bit of transforming and loading into different data warehouses. Could you describe what ETL is and what that has to do with data pipelines?
Yeah, so for those of you who are not familiar with the term, ETL is an abbreviation for extract, transform, and load. And nowadays, the more modern version, I suppose, of that is ELT, which is swap around, so extract, load, and transform. And what that means is just, first you extract data from a source. Those are the sources that I was talking about earlier. Then you apply some transformations to it, and then you load it into your warehouse. The more modern way might be you extract it, and then you just load it without any transformations into your destination. And then with the raw data there, you can apply some transformations. That's ELT. And the advantage of that is that you can always go and apply those transformations again later. If your business requirements change or the transformations you want to apply change, you can just reapply those because you haven't lost any information during the transformation process.
Oh, interesting. Yeah, like the raw data is still there. It allows you to do this.
Yeah, exactly. Yeah, and so CloudQuery focuses more on the ELT aspect, the second one. But you can also do transformations along the way. It's something we're working on actively because sometimes there is a place for that as well. Like sometimes you don't want the raw data, or at least all the raw data, to land in your data warehouse, and you want sensitive data to be redacted and things like that.
Yeah, or you just want to save some money and not save everything.
Yeah, exactly.
All the time. Yeah. Okay, so you're here today to talk about managing complexity in data pipelines. I'm wondering if this just start high level, and can you talk to some like the common reasons why data pipelines get so complicated so quickly?
Yeah, that's a great question. We could talk about different aspects of it, I suppose, but the
Yeah,
first one
I
that
know
comes to
it's not going
mind.
to be a one size fits all answer here.
Yeah, I think the thing that's applied in all the organizations that I've worked in and the data teams I've been in is that the data team is usually a kind of enabling team within the company,
Mm-hmm.
and they are to some extent a middleman between all the other teams. You have product teams who want data and need the insights, and then you have
Yep.
streamline teams, if I can use that term, like engineering teams, basically building the product, and they're providing the data often, but the incentives aren't quite aligned between those
Mm.
two, and you're the middleman. You have to convince the one side to provide the data at high quality,
Yeah.
and then you have to help the other side make sense of the data. And actually, those two parties just need to talk to each other, but
Yeah.
you're somehow now in between, and that's
Stuck in the middle.
fundamentally, I think, one of the big problems. And also because you're interfacing with so many different teams, it gets complicated quickly. You're now
Yeah.
managing lots of different sources, lots of different transformations, lots of different rules and business logic,
Yep.
and you're not really the expert on that as a data engineer typically.
Yep.
You have to refer to others or defer to others to kind of make sense of what's going on, and then when something breaks, everyone looks to you, and you're like, well, it could be the source, it could be the
Yeah.
pipeline, it could be the business logic is wrong. We don't know. Now we have to figure it out. So that I think that's fundamentally what makes a data engineer's job quite difficult when they're building a pipeline. But
Yeah, that
you know,
makes a lot of sense. I mean, it sounds like a lot of what makes software engineering complicated too. Like requirements
yeah,
are always changing. So you're always kind of having to adapt and evolve. And I find too that like data engineering tends, because your customer or like your users tend to be more focused, um, it you get kind of a cumulative effect of kind of like simple, one-off kind of use cases start to become, you can put those together and they work fine. But as like more and more teams start asking you to collect more and more data from more and more different use cases, it
hmm,
can get more complicated.
yep,
And you're absolutely right too. Like you're kind of helping multiple teams, and I think that too. Data engineers tend to be. We talk about like how Conway's law, right? Like a lot of your data starts to look like the organizations that
yeah,
you're building these for, and you kind of start becoming the bridging the gap between these silos of data through your infrastructure, which I think is rare for an engineering unit to do, which I also think is kind of a cool opportunity.
yeah.
Um, they can get
It is
complicated
cool.
fast.
And that is actually, I think, to some extent, like it touches on how data pipelines have evolved over the last decade or so.
Yep.
We saw the introduction of components like Kafka
Yep.
for streaming data pipelines, and the real thing that actually enabled is to decouple all the different teams that are providing data from the different teams that are consuming data. That's the main
How funny.
breakthrough, I think, for that kind of architecture, and it's basically organizational, right? That's
Yeah.
Conway's law, like you said. Like
Yeah.
that's why it works, why it's a nice architecture, because now you don't have this interconnected web of things sending data to each other. You can just kind of send it all to one central place, which is now
Yeah.
the data team, unfortunately for us, and then you send it to all the others, and it is a nicer architecture, and it makes sense organizationally.
Hmm.
But it does put the data engineer or the team as in like quite a precarious position where they're in between everyone. Um, yeah.
I also feel like data engineering and security engineering are the same, that like no one really thinks about you until there's a problem.
Hmm.
Um,
Oh
you're
yeah.
kind of like the I don't know what's the word, and maybe like you don't get respect, but like you're not like appreciated until there's something wrong. Um, so
Yeah. Yeah. There's definitely an element of that.
our
It
job is
depends
to
on the
keep the data
organization. Some,
flowing
like
and
I think,
accurate and up to date.
yeah, exactly. Like as long as the data is flowing, everyone's happy. But it is a bit like, yeah, I think in some of my previous roles, we kind of joked like we're kind of like plumbers. When the hot water stops, then
Yeah.
they're on you. But as long as everything is working, they don't really care. It's all good.
I love that. Can we talk about let's drill into some more specific data quality issues. So we talked about how communication and like different data teams can make data pipeline's complicated, but I think that there are still some more specific components that we could break down. Could you talk about some common data quality issues? That could be things like data duplication, inconsistency with data, incorrect types, missing data, data quality. Can you talk about some of these that might affect data pipelines at scale?
Oof, yeah, I think you touched on a lot of them there.
Did I cover all of them?
And yeah, I think that is still one of the big open questions in the industry to some extent in
Yeah.
data engineering. It's really, really hard to uh, not just to check the data quality. That's already one thing, but also to fix it once you realize it's broken. Also,
Yeah.
once again, because you're connecting all these different teams and sometimes even external sources, and you don't always control the data that's coming in.
Yeah.
So yeah, I think I don't have a specific answer to this. Like I think you touched on all the different types of things that can happen. Like oftentimes duplication you can't really do much about with distributed systems nowadays. You just have to accept that as part of the system essentially.
Yep.
Uh, but then what you have to do is at the very last possible point you do deduplication, like
Yeah.
because then okay, there can't be any duplicates. But throughout the pipeline there may be duplicates, especially if it's like a streaming data pipeline, like
Yeah.
we mentioned Kafka earlier. Then it's almost impossible to really guarantee that there won't be duplicates in many
Yeah.
cases. It's too expensive to do that in a streaming fashion. So you just accept it and you tell people, downstream consumers, they have to deduplicate. Or
Mm-hmm.
usually you have like a kind of silver or gold data set that is deduplicated and is a bit
Yep.
cleaner than just the raw data. And then your data consumers work with that. So that's at least one problem that can be solved, and I think we have kind of an answer for it. But many of the other issues are not as easily tackled. Like you can check your data types. There are tools out there like, now I want to say a Munson. That is one, but that's not the one I was looking for. It's yeah. So Great Expectations, I think, was one of the first maybe attempts to really specifically tackle that problem of data quality and bringing some visibility into the data that's flowing through your pipeline. And it's really valuable. I wouldn't call it a solved problem yet,
Yeah.
but yeah, you definitely need that if you want your organization to make valid decisions based on this data. Otherwise, you might
Yeah. Yeah. Yeah.
think
Yeah.
you have insights, but you actually don't.
Can I just say, Great Expectations is one of the hardest things to Google because you're always going to get the Charles Dickens novel that
Exactly.
pops up.
Yeah.
Yeah. Great product though. I agree. It's still like very complicated. I think even setting it up is still tricky. I feel like as like a data engineering organization or like industry, I feel like we're moving in the right direction for understanding how to like test and validate our data at scale.
Yeah.
Because it's going to be you're going to run into data validation issues. You're going to run into type issues. There's going to be problems with your SQL queries that kind of extract data. And like designing for interruptions in your data architecture and designing for you messing up is the way forward.
Yep. Yep.
It's the only way to make this work. I think, in my humble opinion, like the industry of data engineering and like data, like SQL admin has been, one person has kind of controls the keys to your SQL kingdom, your Oracle kingdom, and they're just kind of putting requests into a black box and they kind of figure out and kind of throw it back to you. But, there's only production of data. They're testing and prod. They're kind of just trying stuff out. And like we have evolved beyond that. We have teams of people. We have more and more data, and we're doing more and more with it. And we're also seeing the rise like data warehousing, like BigQuery and Snowflake are using these like decoupled, storage and compute. So we're seeing like massively decoupled, horizontally scalable data warehouses. Yes, we have to design for that too.
That's a big thing that's changed. Yeah, in the last, I guess, 20 years or so, like these almost infinitely scalable distributed warehouses like BigQuery and Redshift and Snowflake. And it means we also have just a lot more data because there's really like quite a low cost, truth be told, to storing all the data. So you may as well just keep it. But now you have a problem of maintaining the quality and the usefulness of all this data.
Exactly. Do you have any tips for people to try to like what do you do with all this data? How do you keep it useful? How do you know what to keep or not to keep?
Yeah, there are There are different approaches. It also depends very much on the type of data that we're talking
Yeah.
about. Like sometimes within the same data pipeline, we often just talk about events, but within the same data pipeline, you can also have things like logs. You can have things like metrics flowing through. A lot of organizations set it up that way. And
Let's use a specific example. Let's say I'm running an e-commerce site and I'm storing all of my site click traffic, add to carts, buy, session data, and I'm persisting that all in my BigQuery data warehouse. How do I
yeah,
decide what to keep and what to throw out?
I think probably the first thing you need to do is talk to upper management, talk to product, see
Yep.
what are the KPIs,
Yes.
and map those back to data, like raw data tables, and
Herman, can I just
see.
say, you just said the number one thing I've been telling data engineers, and like we are expensive people to hire, and our infrastructure is super expensive. And I think in the zero interest rate era, we could get away with just saving data without any usefulness for it. But I'm going to say it again, like if you can tie your data to either your business saving money or making growing revenue, you're going to have job security.
Yeah,
Um,
exactly.
if you can tie it to a KPI that your boss cares about and like help grow
That's
that KPI, you'll
that's
be in
really the
business.
key. Yeah, if you're not using this data to measure some KPI, I would question whether you need that data
I
at the
agree.
moment, at least.
Yep.
Um, a lot of times you kind of just save it because who knows? Maybe you'll need it one day. But
And you might.
you might. But
Yep.
in my experience, you don't really care about data from more than a year ago, at least, and so
Yeah.
you probably have gotten away with not storing that in the first place.
I am with you. I think tying it to KPIs is the number one way I use to like keep track of like what to throw out and what to keep. And sometimes having historical data there is nice, but trying to figure out like what are the most important things to keep track of, and then you can always change gears later on.
Yeah.
Um, yeah, but it's if you're not using it, it feels like it's even like in my closet at home. Like if I haven't worn clothes for like 6 months, I'm probably not gonna wear it ever
This data
again.
doesn't spark joy,
It
and you
doesn't
throw
spark
it
joy. You
out.
got to Marie Kondo it exactly.
Yeah, yeah, I think that's a good approach. The Marie Kondo approach to data quality.
Maybe it doesn't spark your boss's joy for your boss or the board or stakeholders. I don't know. Okay, cool. Let's see here. I know that there is. So we talked about data validation with data pipelines. Can we talk about like testing and how that fits into that as well too? Something I recommend people do too is not testing in production. So setting up either cloud-based or locally deployable environments for you to do tests on.
Mhm.
Can you
It
talk about that
depends.
a little bit?
Yeah. So yeah, that's one thing about the data pipeline is there are so many different elements to it that you
Yes.
kind of have to ask also at what point do you want to focus your testing efforts. You probably need to test your transformations quite thoroughly, especially
Yeah.
if you're doing ETL, because
Yeah.
then it's apply once
It's
and
gone.
it's gone.
Yeah.
So, you know, and then I think what people often do is they have like the kind of a staging data set that they can test on, and they can, and if you really want to be thorough, you can run some analysis, some statistical analysis on each of the columns and check that they fall within bounds of what you would expect. Like the variance is what you would expect, and you didn't like accidentally null out a column or anything like that.
Yep.
Tools like Great Expectations can help you there again. But you definitely want to do that before you deploy your transformation and find out at the end of the pipeline that, oh, everything is now not meeting expectations. And yeah, I guess the other thing that isn't exactly testing, but it is related to it, is using strong types as much as you
Mm.
can.
Oh
Data
yeah.
pipelines initially, I think a lot of people kind of just threw JSON in there and then hoped
Yeah.
for the best.
Yeah. The
Um,
unstructured, just throw it in your data swamp, figure it
yeah,
out later.
we've learned for lots of reasons that isn't a great approach.
Yeah, I'm with you.
And yeah, so I mean, at CloudQuery, we focused on that quite a bit. We built a specific type system into our source plugins so that it's typed, and we know that if the data is flowing, it's at least the right type and probably is what you expected. And that's from the source side. So usually you can't really test your source side, but you would hope that the person who wrote the source plugin, or if you wrote the source plugin yourself, you did as much testing on that as you could.
Yep.
Using strong types is a good way of validating that it doesn't change too
Yep.
much over time. And then, at least when your source data is good quality, that already helps a lot, like making sure that the rest of the pipeline's data quality is high. But yeah, what are your thoughts on that? Like,
No, I totally agree. I think, yeah, I love what you said too about keeping your source data as high quality as possible. Like if you can ensure some sort of like consistency within your data models too, or like find some sane backups for data that it doesn't exist for some of those data types, I think you're going to be in business. At least be consistent with that, internally consistent as humanly possible, or document, or otherwise it doesn't exist. Yeah, and I think like I was saying too, I think like being able to test either in your own deployed cloud environment too, whether you're using like a clone of production data or production like data. Something I found too by working is you get some like staging environments and you start getting some like production drift in your data sources too, and kind of what that data looks like, which can always be trouble. But the faster you can make a production like environment for testing, I think the better off you and your team are going to be for like managing data pipelines at scale.
yeah, exactly. Yeah.
There's one other piece too I want to talk on that I think is important for managing complexity, and that's around monitoring and logging. Because I think we can set up these tests, we can do these testing, we can deploy these out, and it will still break in the future. Our systems pieces will go down, our Kafka cluster will go down, our data warehouse will go offline, whatever. And I think monitoring and logging is a way to ensure, or maybe, I don't know. I would love to hear your thoughts too on like how to use monitoring and logging kind of in a production like environment to ensure quality.
Ooh, to ensure quality. Yeah. So I think this is a problem that we're kind of slowly waking up to as an industry.
Yeah.
That we've cobbled together a data pipeline or various data pipelines out of off-the-shelf components that were often not designed specifically for data
Yeah.
purposes. Like often you use, workflow orchestration tool that could theoretically orchestrate any workflow, not necessarily a data workflow.
Yep.
And so whatever happens inside is kind of opaque. You just know that either it passed or it failed. That's kind of it. And that's typically okay, but not the best, like not the ideal. The ideal
Yep.
would be knowing that more or less the expected number of rows went through more or less the correct distribution of columns and data and everything. And I'll be honest, I've never gone that far in my data pipelines with the testing approach that validated all this throughout the pipeline. But I think ideally you should, and we should probably work towards having tools that would allow us to do that relatively easily. I think it's always this trade-off between how much work it would be as a company, as a single entity to build something around that.
Totally.
And often the answer is just, it's too much.
Actually, Herman, I just heard of a cool use case actually using CloudQuery. They use CloudQuery to like pull their cloud services to see like which ones were up, and they built like it's like a ledger. It's like a blockchainy kind of ledger that shows kind of what their available services are. And then in their DevOps pipeline, they would check to make sure that all those services in their ledger are like up to date. But using CloudQuery, they're able to go and ping all their services that were up and running and then check that in real time every single time they did a deploy.
That's really cool. Yeah. Yeah, that makes a lot of sense. Yeah, so to touch on logging and monitoring specifically, you have like these orchestration tools that obviously they're actually quite hard to monitor because they run usually on a schedule.
Yeah.
And so the best you can do in terms of monitoring is often just checking, has this workflow run within the last 24 hours or let's say 25 hours? And if it hasn't, then something is wrong. That's like the very most basic check you can kind of do from the outside, again, because these tools aren't aware of the data that's flowing through them. And like some new tools like Dagster are kind of trying to address that problem. But there are other ways as well. You can kind of check at the endpoint where the data is supposed to arrive, like in your data warehouse. Also, maybe do similar checks. Like, okay, maybe you have a cron job. Your data is supposed to arrive at this point by 6 a.m. every day. So at 7 a.m., you run a check that literally runs a SQL query and counts the rows and then alerts you if it doesn't meet expectations. Like, these are pretty basic kind of smoke tests, but they are able to catch, I would say, 90% of big issues. Yeah, logging itself in data pipelines, it's important. It depends. It's like it's incredibly dependent on what exactly which part of the pipeline you're talking about and what type of data you're working with.
Yeah, makes sense.
Yeah.
Let's see here. Herman, is there anything else you want to touch on for tips or tricks for helping people manage complexity with their data pipelines?
Yeah, I think one thing we've kind of embraced at CloudQuery that has helped manage the complexity is, at least we can do this, but we really embraced serverless
Yep.
cloud type services so that we're at least taking away some of those concerns of like, is this machine still running or does it have a failover or anything like. We offload those types of concerns to a third party like
Yep.
Google Cloud or actually ourselves. We also provide a service like that. And yeah, within CloudQuery, we use CloudQuery and our serverless offering to kind of manage these workflows for us and run them at the scheduled time, and we know that
Yep.
it's going to happen, and we can kind of we don't also have to. We can check, of course, that it works, and we should still have monitoring, but it's
Yep.
really on the cloud provider in this case
Right.
to make sure it
Yep.
doesn't fail. And so then we can mainly focus on our business specific problems. Like we can focus on the data quality specifically
Yes.
rather than is the pipeline up or working. And yeah, like I think that's something that's helped us manage this complexity a little bit. The other thing,
Yep.
I guess, that would help, and I'm obviously very biased here, offloading the source part of your pipeline onto a third party as well. Like if you can get away with it, loading the data into your data pipeline or into your data warehouse, rather use someone else's code to do that
Yep.
than write it all yourself. Because writing code yourself comes with maintenance, comes with overhead, and it's always just going to result in higher complexity. But there is, of course, a trade-off. Like you have slightly less flexibility
Yep.
if you don't control that code exactly yourself. So you have to, trust that the people who are writing these upstream sources know what they're doing, and that you have a good relationship with them. If there are issues, that you can service it to them and have it fixed quickly. Yeah.
Can I say too? I think that's a great tip, because like if you're maintaining your own infrastructure, that's an additional piece of complexity you have to worry about on top of the business requirements of the pipelines you're already managing. And I just want to say too, if you're trying to figure out whether you should be building your own solution from scratch or buying someone else's solution, my recommendation generally is that if use someone else's solution unless it gives you like business edge over a competitor. So for example, like if you're Dropbox, managing your own storage infrastructure, it may give you a competitive edge over using a cloud-based version. Otherwise, probably just want to buy it. It's probably going to save you a lot of heartache in the long run.
Yeah,
okay.
Definitely. Yeah, I think that advice applies in general as well as to data pipelines. Like if it's not core to your business,
Yeah.
you can offload it on a third party at a reasonable cost, then you probably should. So
that is the key, at a reasonable cost.
Yeah, at a reasonable cost. That is if you can do it cheaper yourself, then often when you work out like what it's actually going to cost in maintenance and engineering power and all this, then it does work out cheaper often to offload it. Otherwise, those companies probably wouldn't exist.
Well, that's the thing. A lot of people don't take into account their own engineering hours into the cost of a product.
Yeah.
And it does add up. And engineers, I hate to say it, are very expensive.
I guess it's like also opportunity cost. Like if you
opportunity cost.
If your company, if you can use your engineering hours productively to increase your revenue, tenfold, then of course, like focus on the business outcomes in that case. But if there aren't really much you can do in your team or as an engineer to multiply that, but your focus is saving on costs, then maybe it is better to. So it always depends. Like
I agree.
There's always like these trade-offs, but if we can make a rule of thumb, then probably it's better to offload in most cases.
Yeah.
Especially if you're a smaller company.
Yeah.
Because there's a lot more opportunity to grow there.
Let's see here. I want to end here by Herman forcing you to wildly speculate about the future of managing complexity with data pipelines. Mm-hmm. I'm wondering if you can talk at all about trends you're seeing and where you think the data engineering industry might be in 5 years and kind of what that would look like for managing complexity. So the purpose of this is to watch us in 5 years from now and show you how wrong you are about your predictions.
I think when I hear the word wildly speculate, like AI pops into to my
Yeah.
mind immediately. So I have to say something about that, I think. Okay. I think, yeah, I think maybe AI will come into this to some extent.
Yeah.
So, for example, one of the problems we face as engineers or as data engineers is like that the end users of our data often aren't that familiar with the data sets,
Yep.
often aren't experts in managing data and writing queries and so on. This is probably something it seems like large language models will definitely help a lot with. Like they
Yep.
can quickly help you understand the data that's available, quickly help you write queries. Whether those queries will always be 100% correct, maybe in 5 years, I don't, not right now, but it is probably better than you could do yourself in many
Yeah.
cases if you're not an expert. And I think
Yeah, they
that
may
is
not be
gonna,
wildly optimized, but they're probably good enough for a once off, once a month report
yeah, yeah,
for
and
your CEO or whatever.
that I think that will make a huge difference to the usefulness of the data that we send through all these
I
pipelines.
agree. Kind of democratizing and making it easier to access.
Yeah,
Absolutely.
yeah,
I think
easier to
it'll still
find answers.
require an engineer to kind of like make sure the data is clear and consistent and up to date and not borked. But at
Hmm.
least being able to access the data, I think will be much easier, hopefully.
Yeah. In terms of managing complexity specifically, maybe one aspect there again will be in the tooling that we have in 5 years' time
Yeah.
for checking all the way through the pipeline that data fits the expected shape
Yeah.
and types and everything. And since we know that is a lot of work to do today, either we'll have better tools to solve that automatically, or maybe, there will be some AI aspect to this to also just alert us when something is out of place. Like it
Yeah.
seems like machine learning, maybe not large language models specifically, but machine learning in general should be a good tool for solving that problem, for
Yeah.
detecting anomalies and alerting yourself when there's something that you need to look into as a human. So, okay, wildly speculating, but maybe in 5 years
No,
that.
I'm with you. My dream is to have like an AI database Jarvis to like tell me like, hey, this query, this is being queried a lot. An index here could really help, improve performance. We should remove this one; it's not being used very much.
Hmm.
This query has its query planner is ill formatted and it actually is doing a full scan. You should probably be, you know what I mean? Like, I want to like
Yeah,
kind of help keep track of the stuff and like alert stuff for me to kind of bring it up or even auto
exactly.
fix it. Like, hey, I detected this. We could auto sharded your whole cluster for you. Like
That would be
on
cool.
this AP. Like, great.
I
Or kind
think
of
I think we're
readjust things on the
we're
fly.
starting to see the first shoots of that now, even. So I can
Yes.
only imagine that kind of thing growing over the next 5 years.
The
Um,
other thing I'm seeing, Herman, and I'm wondering if you're seeing this too, is I'm seeing a trend towards like platform consolidation. Because the image we showed at the beginning of this episode, the modern data stack is massive. It's a bunch of tiny tools, kind of fitting pipes together and flowing data over the place. But I am seeing a trend towards consolidating, like Microsoft's like Fabric,
hmm,
right? They're like
yeah.
trying to do the entire modern data stack under one product that can kind of like keep it all in house. I'm wondering, what are your thoughts? Do you think that's going to be successful? Do you think it's ready to go? Do you think it'll ever be ready?
Yeah, I think it could happen. But the key for such a tool, whatever tool you choose to consolidate everything, it would have to be massively extensible by nature, by
Yes.
its design, because there are always specific business problems that can only be solved within your business. You have to write custom code. There's no way
Yeah.
around it. So if that tool doesn't allow for that, then it's dead in the water. It's not going to work. But I
Yeah.
agree with you. Like consolidation would certainly help a lot with simplifying these pipelines. If there was only one tool to do all of this, maybe it'll be CloudQuery.
Yeah.
But
Exactly.
we can we can work towards it. Definitely, like our goal is simple, extensible data movement and fast. And so I think we're starting on the right track, and we still need all these other tools at the moment. And
Yeah.
data pipelines are still complex today, but I think the industry is moving to a point where it is becoming simpler, and we are learning how to deal with this problem a slightly in a better way.
Yeah.
But fundamentally, it's a hard problem. Like, yeah, it's just like we mentioned in the beginning, pipelines are very different in different companies, and so it's hard to generalize a solution. Like that's kind of why it's key to have it be very extensible as well.
Yep. Yep. Well said. All right, Herman. let's wrap this up for today. So we talked a lot of different stuff related to managing data pipeline complexity at scale. We talked about a bunch of different ways that it is why it can get complicated, including communication, siloing, and then just issues related to that with data inconsistency and deduplication, validation, and weak typing causing issues down the road. We also talked about 3 different approaches for solving these issues, including testing, validation, and monitoring and logging in production. I just want to wrap up and say, if you're a data engineer working, the worst thing you can do in a data pipeline is create bad data that results in data downtime, where data is either incorrect, it's partial, or it's missing, and it's causing issues for the business that you're trying to service. And those are some strategies you can do to help mitigate and solve those problems. The other thing I'll say too is both of us work for CloudQuery. We're a data movement platform. We solve use cases for monitoring your cloud spend and cloud assets, like monitoring your cloud assets at scale, but we're really a general purpose ETL database or a data movement platform, excuse me. So if you're interested in that, for sure, check that out. We'll have a link to CloudQuery in the description below. If you enjoyed this episode, make sure you like, subscribe, and give us a comment or share this with your friends. We'd love that too. And for any of the resources and whatever we discussed during this conversation today, they'll all be in the description below. I think that's it for today. Thank you so much for joining me. This has been a pleasure.
Yeah, thanks a lot, Joe. It was fun. Always a pleasure. And let's do this again.
All right, deal.
Yeah.